So exercise 13.1, question number 23. Find limit x tends to 0 of f of x. Now limit x tends to 0, this is not a continuous curve because you can see it is broken. So let us find the value of the function f of x. So what is f of x? Limit x tends to 0 of f of x. So let us find the left hand limit and we'll find the right hand limit. So both should be equal. We know that when will you say limit exists? So x tends to a, f of x exists when the left hand limit is equal to the right hand limit. So let us find the left hand limit. So limit x tends to 0. So left hand limit you write 0 minus. So 0 minus means left of 0 of f of x. So it is equal to limit x tends to 0 less than 0, the function is 2x plus 3, right? Can you see that? It is less than 0, the function is 2x plus 3. So it is 2x plus 3. So you should write here 2x plus 3. So we can substitute here x as 0. As usual, it is 0 minus. 0 minus means left of 0. So just substitute. How do you find the limit? You just substitute x is equal to this value. If it is only in the determinant form, you go to the next step. So it is substitute x is equal to 0 here. So you get 2 into 0 plus 3, that is equal to 3. Now come to the right hand limit. Limit x tends to, so limit x tends to 0 plus of f of x. So it is equal to limit x tends to 0 plus. Now right of 0, the function is 3x plus 1. Okay. So it's different function. Left of 0 one function, right of 0 is another function. So it is equal to limit, substitute x is 0. So 3 into 0 plus 1. So it is equal to 3 itself. So we can see here the left hand limit is equal to right hand limit is equal to 3. Therefore, the limit of the function x tends to 0 of f of x is equal to 3. You can also do by taking, see if I want to find left hand limit, I just do that method also because you should know in some notebooks, some books, textbooks, they would have given the other way. So if it is left hand limit, so suppose this is 0, left of 0, if you want to find the left of 0, you just take it as 0 minus h, that x is 0, no? So left of 0, take it as 0 minus h. So right of 0, take it as 0 plus h. So when x, so x is 0 minus h for the left hand limit. So when x tends to 0, when x is 0, approaching 0, what happens to h? H will approach 0. Okay. Similarly for the right hand limit also, when you put x is equal to 0 plus h. So when x tends to 0, h tends to 0. So here the same question I'll do with the method. Left hand limit, I'll do the next one. This is the same question, you have another part. Yeah, I'll do this using the second method. Okay, this one I'll do. Limit x tends to 1 they asked. So left hand limit is equal to x tends to 0 minus of f of x. So that is limit x tends to 0 minus, the function is 2x plus 3. So you can write this as limit h tends to 0. Just replace it as h tends to 0. Take this x as 0 minus h plus 3. So when you substitute h as 0, you will get 3. Isn't it? When you put h is equal to 0, you get 3. So the left hand limit is 3. The same way you can find the right hand limit. So right hand limit is limit x tends to 0 plus of f of x. So that is limit x tends to 0 plus, the right hand function is 3 into x plus 1. It is 3 into x plus 1. So you write this as h tends to 0, 3 into, you replace x by now 0 plus h. So it is 0 minus h for the left hand limit, 0 plus h plus 1. Okay. So when you put h is 0, this will become 0 plus 1, that is 3. So you write the left hand limit is equal to right hand limit, the limit exists. So you can do like this also. Limit x tends to 0 of f of x is equal to 3. Now the same question they ask you to find limit x tends to 1. The second part of the question is limit x tends to 1 of the function f of x. You remember that first the concept, when you learn the concept, some of the functions, see for example if you want to find the limit of a function x tends to x plus 3. Now this graph when you draw, at x is equal to 0, what is the value of the function? F of 0 is 3, right? The value of the function is 3. Now because it is a polynomial, it is a linear equation, left of 0, you take a number left of 0, it will be approaching 3, it is not exactly 3. Just take a number left of, substitute it here and then add this, you get approximately 2.9999, right? If you take a number right of 0 and substitute, right of 0 means 0.00001, put it here, what do you get? Approximately you will get 3.00001, something like that. So left limit and right limit both will be approaching 3. So we say the limit is 3. So first thing, whenever we are asked to find the limit, the first step, we did so many sums. Yeah, substitute 0 and check whether left limit is equal to right limit. Function need not exist always. Function may not exist, function may go to infinity, but left limit will be approaching 2.999. Right limit will be approaching 3.0001. The function doesn't exist. So we had, remember that we had problems like that also. For example, you take a function, this function we took x square minus 4 by x minus 2, find limit x tends to 2. Now okay, so at 2 the function is not defined, okay, because you substitute at 2, 4 minus 4, 0 by 0, indeterminate form, but you can take a number left of 2, 1.99999, and you can take a number right of 2, that is 2.0001, substitute it here, substitute and check what do you get, approximately 3.9 something like that. Left limit will approaching this and this will be reaching 4.001. So we say the left hand side the function is approaching 4, right hand side the function is approaching 4, therefore the limit is 4. So what we should do, first you substitute straight away. If you are getting 0 by 0, that means the function doesn't exist. So what is the next step? You have to factorize it and remove the factor that gives you the 0 by 0. So here you factorize it, so you get x plus 2. Now substitute x is equal to 2, you get 4. See, that means the limit is 4. That means it is left side is approaching 4, right side is approaching 4. At x is equal to 2, it is not defined. So the left of this function, left of 0, it is given as 2x plus 3, right? The left side function is 2x, left of 0, and right of 0, 3 into x plus 1. This is what is given, right side. Now where is 1? 1 is somewhere here, isn't it? At 1. So we have, the question is find the limit at x is equal to 1. So left of 1, what will be left of 1? What is the function left of 1? This is the function. We cannot take 2x plus 3. Left of 1 means very close to 1. So the function which is very close to 1 is 3 into x plus 1. Left of 1 and right of 1 also you take the same function. You won't go to this function at all. We are not using at all because it is very far. It is left of 0, it is left of 0 and right of 0. So left of 1 and right of 1, we have to take this function. substitute the values now. Let us find the left limit and the right limit. So left hand limit is limit x tends to 1 minus of f of x. So that is limit x tends to 1. So left of 1 and right of 0. Okay, right of 0, this is the function. So this is the function which is left of 1. So that is 3 into x plus 1. So just put x is 1. Straight away put x is 1. Substituting actually a number very close to 1, because it is a polynomial, you will get approximately the same value. So whenever you have to find the limit, substitute this value, the value here, as you substitute to find the value of the function, is equal to 6. So now you find the right hand limit. So the right hand limit is limit x tends to 1 plus of f of x. So that is limit x tends to 1 plus same function, right of 1, that is right of 0, it is 3x plus 1, right of 1 also same thing, 3 into x plus 1. So again 6. So the left hand limit is equal to the right hand limit is equal to 6. So the limit value is 6. Is 6. Okay. So whenever you have to find the limit, first if it is a polynomial, you just substitute, you will get the answer straight away. The problem will be only when it is a rational function.